Okay, everybody, here is the review for today's, actually for tomorrow's quiz. So I'll go through this in case you want to watch it, and it's going to be online on Canvas, so I have to just watch. Okay, so if we're going to graph number 1, okay, so actually I'll use 2 different colors because sometimes that's easier for you guys to see 2 different colors. So graph 1, okay, solve this system by graphing both lines and finding the point of intersection. Easy. Start at -4 on the y-intercept. Right there, slope up 3, 1, 2, 3 over 1, 2, 3, 4, 1, 1, 2, 3, 1, 2, 3, 4, it's over there. Okay, and then the second equation, I'm going to do in blue. I'll start at +4, 1, 2, 3, 4. I will go down 1 over 1, 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 down 1 over 1. Okay, so and it looks to me like they don't quite intersect by 1, 2, 3, 4, yeah. But they're awfully close. So I'd say that we can estimate their point of intersection at 1, 2, 3, 4, about 4.5, and about, maybe -1/2. Now, of course, that's only an estimate. That's why we need to do this a different way. So we take a look at the second example. The second example says solve these equations by any method. Well, I'm not going to graph it because graphing seems to be the most inaccurate and it's more tedious. So I'm going to solve this. First of all, in this example, they both equal y. So if they both equal y, then x minus 2 must equal -x plus 4. So I'm going to set them equal by substitution. So I'll take an x minus 2 and I'll set it equal to a -x plus 4. If this equals y, if they both equal y, they equal each other. And I'm just going to solve, okay? So plus x, I'll have a 2x minus 2 equals 4, plus 2, I've got a 2x equals 6, divide by 2, and x is 3. Okay, so then I know I'm looking for a point, like this example. So I know my point is at 3 something. To get the something, I'm going to do a substitution. I'm going to take my 3 and plug it into either equation, but probably into this one. Seems like the easiest. So I'm going to bring this equation down here. I've got my y equals x minus 2. Well, this is pretty easy because I'll put my 3 in for x because that's what it says it equals. So I'll rewrite this as y equals, well, 3 because x is equal to 3 minus 2. And of course 3 minus 2 is going to be a 1. So my point of intersection without graphing is at the point 3, 1. I like that. Okay, number 3. Same thing. I could do it by graphing, but that seems to be the most tedious. What I do notice about number 3 is that y is already solved for. It says y equals 5 minus 2x. So I will do substitution. I will plug my 5 minus 2x in for y. I'll just rewrite it right there. So when I do substitution, I like to write them side by side. It's just been the way I've always done it. 3x minus 2y equals 4. And a y equals a 5 minus 2x. Okay, so if I'm going to substitute, I'm going to put this 5 minus 2x, that's what y equals. Y is equal to 5 minus 2x in for y, in the other equation. So instead of writing y, I'll write 5 minus x. So it's going to look like this, 3x minus 2. But I'm not going to put y in, I'm going to put 5 minus 2x equals 4. So I just replace y with what? Y equals 5 minus 2x. Now I'm going to simplify. I'll get a 3x. I'll get a minus 10 plus 4x equals 4, right? I'm solving. That's a 7x minus 10 equals 4, right? Plus 10, 7x equals 14. Divide by 2, and x is going to be, divide by 7, x is 2. Okay? Now again, my answer's got to be a point, so I need the y value, so I'll just take this 2, which is x, and I'll plug it right in there. So I'll rewrite this one. This equation is a y equals 5 minus 2, and I'm not going to write the value of x, but I'm going to write what x is equal to, which is a 2. And then let's see what I get. I get a y equals a 5 minus a 4. I get y equals a 1, so my solution, my answer is x, y, or 2, 1. On number 4, okay, if I look at number 4, well, they're lined up, and I'm going to do elimination. I'm going to do by elimination. So to eliminate, I think I'll probably multiply the second equation by 2. So I get a 2y, negative 2y. So let me rewrite equation 1. Equation 1 is going to be an x minus a 2y equals negative 6. And equation 2 now is a 4x plus a 2y equals a negative 4. And when I add them, the y's cancel. It's awesome, I like that. Y's disappear. And I get a 5x equals negative 10. Divide by 5, I get x equals negative 2. Now I need the y value. I need the y value, so I can plug this x equals negative 2 into either one. This one looks easiest, doesn't it? So I'll plug the negative 2 in there. So I'll rewrite my equation 2, 2x plus y equals negative 2. But instead of writing x, I'll write negative 2 right there. So I'll rewrite this as 2 times negative 2 plus y equals negative 2. That's a negative 4 plus y equals negative 2 plus 4, I get y equals positive 2. So my answer as a point is going to be negative 2, 2. Okay, that's the point of intersection. Okay, all right, number 5. Well, first of all, they're backwards. I got to rewrite them. So let's rewrite. So I'll have a 3x plus y equals 12, and I'll switch them around. I want the 3x plus y equals 10. Oh my, they look like the same equation almost, right? Let's go ahead and subtract these two equations. Let's subtract, multiply through by negative 1 on this one. So if I multiply through a negative 1, the x's will cancel, and the y's, I think. So 3x plus y equals 12. But equation 2 becomes a negative 3x minus a 1y equals a negative 10, and I get 0 equals 2. What? Well, that's got to be parallel lines, which means that there is no solution. They don't intersect. Okay, that's my answer. No solution. Hopefully this seems pretty easy. Okay, I'm going to turn the page. Let's take a look at the next one. Sorry about that. I didn't show that very well, but there it is. Okay, turn the page. All right, I got a third problem. We can do this. Okay, the senior class is raising money for their senior trip. They're selling chocolates, boxes, and fruit baskets. Let's just call that X and a Y. Okay. At the end of the season, they collected $1,160 from selling a total of 160 gifts. The cost of chocolates was $8, and fruit basket was $5. Okay, two equations. What? Okay, first of all, equation has to be number of gifts. It has to be the number of gifts. So I'm going to have a x plus y equals, well, how many? 160, right? So I've got the number of gifts. I've got my chocolate boxes, my fruit baskets. Number of those equals 160. The second equation has to be the cost or income. Cost, income, money. What do you want to call it? Money equation. And that's going to be a 9x plus a 5y equals my 1,160. Okay, so let's graph this. Okay, so first of all, by intercepts. That's the way I like to graph them. We got an x plus y equals 160. By intercepts, I get x equals 160, and I get a y equals 160. Okay, so I probably need to go by 20, 2, 4, 6, 8, 10, 12, 14, 16. I can probably go by 20s. 20, 40, 60, 80. Let me double check my other intercepts. Let's see. 9x plus 5y equals 1160. X equals, if I divide by, cover it up, right? And I would go 1160 divided by 9. I get about 129, about approximately 129. And then the y equals 1160 divided by 5. About y is about 232. Okay, hold on. 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. It's going to be a lot. Okay, so if I go by 25s, I'll go by 25s. 25, there's 100. 1, 2, 3, 4. There's 200, and I can estimate. There's 100. Whoops. 1, 2, 3. There's 100. 1, 2, 3, 4. There's 200, and there's 250. Okay, I can do that. And let me make this dark. And I think I have chocolates on the bottom, so let me go ahead and make my scales correct. All right. I can do this. Chocolates. And this is going to be fruit baskets. All right, so let's see here. I'm going to have an intercept of, and I'll do this one in blue. Okay, this one in blue. X plus y, so 160 is about there. 160 is about there, and 160 is about there. Connect the dots. That's my first equation. And then the other equation, let's see, I'm going to have 129 for x. Do this one in pink. 129, about there maybe. And 232. 232 is about maybe right up there. All right. So the intersection is right about there. There's my intersection. I know it's there, but it's too hard to tell what it is. So let's do it algebraically. Okay, so to do it algebraically, we're going to set this up. We're going to go that x plus y equals 160, and then 9x plus 5y equals 1160. I want to do it by the elimination method, so I think I'll multiply the first equation by -5. So equation 1, equation 2, equation 1, I'll have a -5x minus a 5y equals, I don't know, hold on, that's what this is made for. 160 times -5, -800, and then equation 2 is my 9x plus 5y equals 1160. Add the two equations, I get a 4x equals, hold on, 360 divided by 4, and I think I get 90, right? So I need 90 chocolate. I need 90 chocolate baskets, okay? So what about fruit? Well, let's plug it in. Well, obviously, let's take the 90 and plug it into there. That's the easy equation. Okay, so I have my x plus y equals 90, but I'll put 90 in for x. So I've got 90 plus y equals 160, silly me. 160 minus 90 minus 90, and I'm going to get what? And I get 70. So I need 70 fruit baskets. Okay, there's my answers. There and there. That's all I have. Good luck tomorrow on the test. I'm sure you're going to do great.